In this lecture, we will cover iterative structure examples. Let's look at this example. It is an iterative structure, which is a loop. You will find this structure unique and powerful. It eliminates the need to repeat code over and over again. It allows you to dynamically build an algorithm since you do not know how many times you need to loop. This example shows you how to do that. Given a positive integer, create an algorithm that will sum and display the total of all integers from 1 to a given number. If someone wants to input 10, we can add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. The answer equals 55. Think about how you would do this with conditional and sequential structures. This would be very difficult without the iterative structure. In this example, you need to set up a counter to control the loop, and that's what you see here. Counts equals 1. Now, this allows us to exit the loop. So each time we go through the loop, we will increment the counter and we will hit this condition when the counter exceeds whatever our integer is, and that will exit the loop. Once again, we talked about this earlier. Without this line of code, you will have an infinite loop. So let's go on and walk through this together. Do until count is greater than integer. Let's go on and use 5 as an example. So our input, integer of 5, output, total. So we will get integer, which is 5, set the count equal to 1, do until count greater than integer. So right now count is 1, integer is 5. So we will add count, which is 1, to the total. So right now the total is 1. Then we increment the counter by 1, so now the count is 2. 2 is not greater than 5, so we are going to add 2 to 1. Now we have 3 in our total. Let's go on and increment the counter. We have 3. We are going to continue. 3 is not greater than 5. Now we have 3 plus 3, which is 6. Increment the counter, which is 4. 4 is not greater than 5, so now we will add 4 to our total of 6. Now we have 10. Add 1 to the counter. Now we have 5. 5 is not greater than 5, so we will add 5 to our total of 10. Now we have 15. This is where we increment the counter. Now we are at 6. 6 is greater than 5. So we get out of the loop and we will execute the next statement. In this example, we should have display total. Now let's look at test cases. So here's an example of test case 1. If we input an integer value of 10, if you go through this logic here, your expected result should be 55. Now the other thing we want to do, we want to make sure we test the opposite. We will not execute this loop. Why? Because the input is 0. Do until count, which is 1, is greater than 0. You will never execute this, and your expected result will be a total of 0. So make sure you do the positive, which is going into the loop, and the negative, which is not going into the loop. So you want to test that out. Go back and try some other numbers and make sure this logic makes sense to you. If you have any questions, be sure to watch the video again or reach out to your instructor. Let's look at this example. We are going to write a solution to find the average miles per gallon on a car after 4 fill-ups at the gas station. Some of the data that you want to get the number of gallons of gas at each fill-up, the starting odometer reading, and the odometer reading at each fill-up. We fill up the gas tank and we mark the odometer readings. We are going to loop through 4 fill-ups. Notice how you get your information inside the loop. Our input gallons, starting odometer, odometer reading. Our output MPG as in miles per gallon. Set the count to 1. Set total gallons to 0. Set total miles to 0. You are going to loop while the count is less than 4. Inside, we do a get gallons, starting odometer, odometer reading. Then we total up the gallons. Gallons added to total gallons gives us the new total gallon. We're going to do the same thing with total miles. Total miles equals total miles plus the odometer reading minus the starting odometer. And now we need to add 1 to the counter. Remember, this is how we exit the loop with this logic right here. So you will continue to loop, and once you finish, you will calculate the miles per gallon by taking your total miles and dividing it by total gallons. Let's walk through this test case. In our first fill-up, we have 10 gallons, odometer reading of 0, start 0, reading of 0. Second fill-up, 20 gallons, starting odometer 0, odometer reading 300. Third fill-up, 20 gallons, start odometer 300, odometer reading 700. Fourth fill-up, 15 gallons, starting odometer 700, odometer reading 1100. If you run through the math on this and you follow the logic in the previous slide, your expected result should be rounded up to 17 miles per gallon. So you need to run through that logic and create your test cases. And this is one test case just to show you the data. Well, let's go back and look at the code. You need to be sure you fully understand how to create this loop. You need to understand your logic inside the loop and how you exit the loop. So be sure you understand this and how it relates to your condition here. For your assignments, make sure you understand what you are repeating each time. If you are confused, just write the code out and recognize the parts of the code that are repeating. When you finish, wrap it with a loop to figure out the condition that controls the number of times you need to do it. Be patient. Take your time and practice with the assignments. We are teaching you to think like a programmer. Relax. Take your time. We have more time to practice, so please do not get frustrated. If you are confused, be sure to ask your instructor, and you may want to watch the videos again. Try to have fun with your assignments and test cases. This concludes our lecture. Thanks, and see you next time.